Hello, welcome to the final review for Stat Methods, Summer B, okay, or whichever semester. This just happens to be Summer B. So here are the main things that you guys need to concentrate on what we've done throughout the year, and I'm going to talk about these a little bit. This is going to be a pretty short review because we've already learned all this stuff. You just have to go back into your homeworks and practice it. Okay, so the first thing is table probabilities. So table probabilities are all these and, ors, or given. Okay, especially these two right here. You guys need to concentrate on. But basically, this is when we did the one that was like driver intoxicated, driver not intoxicated, pedestrian intoxicated, pedestrian not intoxicated, and they gave you these numbers here, like let's say 100, 200. 150 and 100, something like this. And it was like, what's the probability that the driver's intoxicated or the pedestrian was intoxicated, something like that. And then you'd have to go through all these and see, well, which situation was the driver intoxicated or the pedestrian intoxicated. Okay, so driver intoxicated. Okay, so if you look at the driver's intoxicated, both of these drivers were intoxicated, so those need to be included. If you look at the pedestrian, both of these pedestrians were included. So if you look at the 100 got circled twice. Okay, so we don't actually want the 100 twice, we only want it once. Okay, so it's going to be 100 plus 200 plus 150, so it'd be 450 divided by however many total people that we have. So 1, 2, 450 over 550. So that's how you do an OR. So a given would be something like, what's the probability that the driver was intoxicated given the pedestrian was intoxicated? Okay, so we're given this we're given the pedestrian was intoxicated. So if the pedestrian's intoxicated, so that would be 250. We have 250 accidents where the pedestrian was intoxicated. So out of all these 250, how many of these 250 was the driver intoxicated? That would be 100. Okay, so that's a quick example of how to do a given in an OR. Okay, probability of a area under a curve, something like if it said the mean was 100, standard deviation is 15, and if I pick one person, what's the probability that their score would be like greater or equal to than 120? Okay, so you go to your normal calculator. This is the normal calculator. Okay, and everybody should be comfortable for that. Okay, so this would be kind of similar to this problem, but I'm asking it backwards. I'd say, oh, the average is 100, the standard deviation is 15, and I'd say something like, what's the score for the lowest 5%? So you go to your normal calculator again, but the only difference is here is you do something like this. Probability X is, since I said lowest, you want to make this a less than or equal to. Leave this blank, leave that blank, and then put in 0.05, and your answer will pop up here after you hit enter. Okay, so go back and do some of those. Okay, a binomial distribution is when we're interested in X, successes, and N trials. So one thing you have to be comfortable with these is you have to be able to figure out N, how many trials, okay, and what's the probability of a success. That's P. P is the probability of a success. These are the important things you have to know in a binomial, and then you go to the binom calculator. Okay, so that's by the normal calculator, but it's a binom calculator. Put NP, and then they're going to ask for how many successes. You say, at least, or at most, or exactly. That's where you put in the probability of the X. Okay, this would be the X. You put the N and the P there. Probability of a success on one trial. That's what this P is right here. Okay, combination permutation. This is like how many ways we could arrange, or how many different combinations or permutations we could have in a group of people. Okay, so remember, when order matters, that means that 1, 2, and 3 is completely different than 3, 2, and 1. That would be a permutation. permutation, and that would be NPR. Okay, and go back and look at your formulas for these, for the NPR. Order matters. That means 1, 2, 3, and 3, 2, 1 are two people. So if you're picking people for like a committee, then it'd be like president, vice president, secretary would be different than if the third one was the president. You see how that's different possibilities? See this one, if this would be the president and VP and secretary, and if this was president, VP, and secretary, these are two different possibilities because see here 1 is the president and here 3 is the president. That's two different outcomes. So you have to account for every different outcome of 1, 2, and 3. Okay, so that'd be a permutation. The other aspect would be a combination where order doesn't matter. And you guys need to go back and look at your formulas or figure out how you guys did this before, but this is NCR, and in NCR order doesn't matter. So this would be like 1, 2, and 3, and 3, 2, 1, and all these different arrangements of 1, 2, and 3, and 3, 2, 1 all count for one possibility. This is one possibility. For example, if you were picking a sample, if you had 10 people and you were picking, and R was equal to 3, you were picking 3 people out of those. So if you pick 1, 2, 3, say you were taking them on a trip or something, if you took 1, 2, and 3, well, those are the same people as 3, 2, 1. So it's the same group of 3 people, so they would only count as one. So all these different arrangements, 1, 2, 3, 3, 2, 1, 2, 1, 3, 1, 3, 2, all these different arrangements of 3 would only count as one possibility. So there's always less combinations than there are permutations. Alright, line reg, make sure that you're okay with finding a least square regression line. Least square regression line, that's the equation that we make predictions. Then make a prediction. Okay, we just did that. Okay, confidence intervals. Okay, these are all multiple choice. So you're going to need some confidence intervals here. So be sure you're comfortable with these, okay? So it's either going to go the proportion side or it's going to go the mean side. Remember, it's the mean side. This is the easy one. Okay, this is just x and n. N is how many people and x is how many successes out of those proportions. But if you get a if you get a mean, then it could kind of branch out. Remember, if sigma is known, we use the z's. If sigma is unknown, we use the t's. Okay? So be comfortable using StatCrunch on how to do this. They're just basic confidence intervals. Go back and practice some of those. Okay, the frequency table is how we organize data. We did this at the beginning of the year. You get a set of data. Okay, the first thing you should do is find the class width. That's going to be the max minus the min. You get the range. You divide by the number of classes. And then we always round up. Okay? You always round up, and then make sure you count those numbers. Okay? Make sure you count. So let's say we started at 1 and there was a whole bunch of numbers and we ended at 10. Say the class width is 5. So it would be 1, 2, 3, 4, 5. Okay? So it would be 1 to 5. See, 1, 2, 3, 4, 5. So you start at 1. You don't start at 2. Okay, so the next class would be 6, 7, 8, 9, 10. So it would be 6 to 10, etc. Okay. All right, box plots. You need to be able to make sure you go to your stat summary and get your 5-number summary. That's the min, Q1, median, Q3, and max. It's going to look something like this. Okay. And the shape, this one would actually be symmetric because these two boxes, what's happening over here kind of images over here. Okay, if this thing was a little bigger, then it would be skewed right. If this tail was bigger, or if this box over here to the right, it would be bigger, it would be skewed right. If this box would be bigger, it would be skewed left. Okay. All right. So here's the mean problem. Make sure you can draw the graph, draw a normal curve, shade that normal curve. Make sure you label it with the mean. This is the lower limit. That's the upper limit. The standard deviation depends on what we're at. If you see this one right here, find area under a curve, this was just one person. So if these are all x bars, if these are all x bars, then the standard deviation of your x bars is sigma over the square root of n. Okay, that's the biggest mistake. So, but basically you're going to draw this out and then use your normal calculator. Okay, now we got two hypothesis tests. Okay, and these could be anywhere from proportions to means, etc. So go back, chapter 8 and 9, and practice on your hypothesis steps. The 4 steps is the hypothesis, which is the null and alternative. That's step 1. Then you need your test statistic. It's either going to be a z or a t. That's the second step. Then you need a p-value. Okay, which StatCrunch will give you, and then you need to make your decision / conclusion. Okay, so that's it for the review. This pretty much narrows it down for you pretty well. Just make sure you study. You guys have till Monday to study, and thanks.